So we'll understand Huffman coding with this example. What is the idea of Huffman coding? Huffman coding actually computes the shortest expected length of prefix code. That is, we'll attach a prefix. We saw how to create prefixes in the last session, but that was arbitrary. We constructed the table by whatever we were able to think. That was not based on any algorithm. That is, we took 0, then 1 0, then 1 1 0 and 1 1 1. That was arbitrary. How to construct that prefix code? This is what we do by Huffman coding. Clear? We put prefixes. We put prefixes in sending a digital sequence of symbols. Now, how to create efficient prefixes, shortest length code words. So that is done by Huffman coding. Okay, so by this algorithm we create prefixes. So let's see how we create it, because explaining this is very difficult. You won't understand if I talk theory of Huffman coding. Let's see this by example. What we do, first step is we arrange the symbols in descending order of their probabilities. That is, this is symbol, see, this is 0.4, 0.2, 0.2, 0.1, 0.1. So like this, not that 0.4, then 0.1, then 0.2, no. We arrange in descending order of the probabilities. Then the last two lowest probabilities, we add them up. This is called splitting stage. So we add these two. This becomes 0.1 and 0.2. Now the next level, what we do, this probability is 0.4. Now this is 0.2, 0.2, 0.2. This is, we have to make decision whether to keep this at this point, this at this point, and this at third point. Or what we can do, we can put this here 0.2 and we can shift it here and we can shift it here 0.2. Clear? We have two choices here and both are used. We can either put it directly here and these two in front of them, or we can take this to the highest level and shift them down. This is a better way. Why? Because it creates the minimum variance. I'll talk of this thing later on, but for now keep this in mind. Now again, what we do, we add these two, and what we do, we assign them value. This one 0 and this one 1. Again, the question, you can ask me, why not 1 and 0? We can assign 1 and 0 also, but the usual way is to assign 0 and then 1. Now second, this is 0.4. We have 0.4 here also. So what we'll do, by convention, we'll put 0.4, this 0.4 to the top. Okay, and then shift this 0.4 here, and then we have 0.2. Okay, then add these two. So what do we get? We get 0.6, and this is shifted to this point 0.4. Okay, so 0 1 0 1 0 1, and then assign this as 0 1. Okay, this is clear. Now how to make codes? See, this is S0, S1, S2, S3, S4. How to find the code for S0? Start with this. See, we are going this point, then it went to this point. That is, there's 1 0. Then again what happened? It went to this point, which is 0. So we start from here to here. So the symbols associated that we have given to S0, here we don't have any symbol, here we don't have any symbol. First time we have symbol here is 0, and second time here is 0. So symbol for 0, S0 will be 0 0. See, 0 0. This is symbol for, or code for S0. Then S1. See, S1. Here we don't have any symbol. Here it has a symbol 0. Then again it goes to this point, no symbol. Then it goes to this point. Here we have a symbol 1. So 1 and 0. So oh, this becomes 1 and 0. Now S2, from here it goes 0, 1, then 1. So S2 becomes 1, 1, 1, 1. Then S3, see, S3, it is 0, then goes here, then here 1, okay, and then again 0. So 0, 1, 0, 0, 1, 0. And then S4, we have 1, 1, 0, that is 0, 1, 1. So 0, 1, 1. So we have assigned prefixes. S0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 0, 1, 1. Clear? And using a decision tree, you know how we can do that? If it is 0, 0, if it is 1, 0, we can make a decision tree which takes the first digit. If it is 0, it will send to S0. If it is 1, it will go to the next node. Then again 0 and 1. So this way it will take it. So this is called Huffman coding. This algorithm is Huffman coding. So in this way we create prefixes. You understand the difference? The first time when I was talking of prefix coding, instantaneous codes, what I was doing, I took 4 codes arbitrarily. Why? To make you understand. Now I am telling you how to make such prefix codes. So we do that by using Huffman coding. This is the way we create Huffman coding. Try to understand this properly. You need to understand it once only. Once you understand it, it's for always. Okay. So what are the drawbacks of Huffman coding, or I shouldn't say drawbacks. What are the critical points in Huffman coding that need to be understood? First is we arranged it in descending order of the probabilities. That is okay. Now we added the lowest 2 probabilities and made them up in the probability scale. But we could have taken it at the lowest point, or we could have taken to the uppermost point. This is the first issue. Second is whether to take 0 and 1 or 1 or 0 at the splitting stage. So these are 2 particular critical points that need to be taken into account. The transmitter and the receiver both should have a proper communication what we are taking. Then only the code will be uniquely decodable. So for the code to be uniquely decodable at the receiver, this has to be clear between the transmitter and the receiver. Now the code word lengths are varying. We have 2, we have 3. So for 5 symbols we have this difference. If there are hundreds of symbols, the code word length will be varying. So if LK is, let's say LK is the code word length of the SK symbol, then we have variance. We define variance. You know statistically what is the meaning of variance. So variance here, that is average code word length is L. So how much it differs? So this is given by Pk, that is the probability, kth probability, into this Lk minus L square, k equal to 0 to k minus 1. This is an important figure. It shows the variance, that is how much, if the code word length, the average code word length is 10 and variance you have from 1 code word length to 100 code word length, n is from either 1 or not either, from 1 to 100, variance is very high. What we we wish variance to be very low. So this is an important figure to be taken into account when we are designing codes. And how to find HS entropy and how to find the average code word length. I have found the average code word length in last example also. Here also we can find this L. How? It is equal to summation Pk into Lk. K equal to this, that is from 0 to 4. We take the summation. So S0, the code word length is 2. See, 2 into its probability. S0 is 0.4. Then 2 into 0.2. Again 2 into third probability is 0.2. Then 3 into the probability is 1 and 1, 0.1, 0.1. So 0.1 plus 3 into 0.1. Okay, so if you add them all, so if you add them all, what you get is 2.2. That is, your average code word length is 2.2 binary information. Okay, so L is 2.2. Now the second quantity is entropy. How you take entropy? You take summation of pk into log 1 by pk, or it is k equal to 0 to k minus 1, or minus log pk. So this will be 0.4 minus 0.4 log 0.4, then 0.2, 0.2 log 0.2, then you have again 0.2, then 0.1. So add them. If you add them all, this comes to 2.121 binary information bits. So from here also, what you saw, that L, that is 2.2. So L is, see, greater than or equal to HS. So this condition is satisfied here. Okay, so this is how you do Huffman coding. This is how you can find the entropy. This is how you can find this thing. And you have LK and all. If you want to find a variance, how will you do that? Variance, I told you, is given as summation pk into LK minus L square. So how can you find variance here? Variance will be, see, for S0 pk 0.4 into LK. LK is here 2, and our average code word length was 2.2. So 2.2 square plus 0.2. Okay, then again here is 2. So this is 2 minus 2 and so on. So you can add them all and get the value. You will get variance. Clear?